Hello everyone, this is Revathi working as an assistant professor in information technology from SNS College of Engineering. In my today lecture series, we are going to see about Floyd's algorithm. Floyd's algorithm, also known as Floyd-Warshall algorithm, is used for finding the shortest paths between all pair of vertices in a weighted graph with positive or negative weights. It works by comparing all possible paths through the graph and recording the minimum distance for each vertex pair. Then the Floyd's algorithm is also called as Roy-Warshall algorithm or the Roy-Floyd algorithm or WFI algorithm. Here is one example given for solving the Floyd's algorithm. We can easily understand the concept of the Floyd's algorithm. Here the given graph is having four vertices and it is also having some paths between them, and it also having weights between two nodes. Here the A to B is having 2, then B to C is having 1, and C to D is having 3, and B to D is having 5, and A to C is having 4. Here the path 1 will be the source node is A and the destination will be D. We have to reach from source to destination using in some of the intermediate nodes. Here the path 1 will be find out A to B and B to D. The intermediate node is here B. The total path will be calculated as 2 plus 5 is equal to 7. Then the path 2 A to C, C to D is calculated for the next path, and also the weight of this path is 7. Then path 3 A to B, B to C, C to D. Here the weight is 6. And there are several things to notice here is there can be more than one route between two nodes will be available. The number of nodes in the route is not important. Both path 3 has 4 nodes but in shorter than path 1 or 2 which has 3 nodes. There can be more than one path of minimal length will be taken for the resultant. And there are several things to notice here is distance table by uh, denoted by d0, d1, d2 up to dn. Then the sequence table will be calculated as s0, s1, s2 up to sn. The iteration will be denoted by k. Here the rows and columns are named as its name of the vertex A, B, C, D. This is the column name and the row names are also A, B, C, D. Here the A to A is 0 always. Then A to B will be having direct path. So the weight of that path will be noted here. Then A to C as 4, A to D will be denoted as infinitive. A to D will not having direct path, so it will be denoted as infinitive. Then B to A is 2, then B to B is known as 0, then B to C is 1, B to D is 5, then C to A is 4, C to B is 1, and C to C is denoted as 0, then C to D is 3, then D to A is infinitive, then D to B is 5, D to C is 3, and D to D will be known as infinitive. Likewise, the all infinitive will be replaced by some value. Then the resultant of this value is calculated as d of ij is greater than d of ik plus t of kj. If the intermediate path is present between the source and destination node means it will be calculated using this formula. Otherwise, it will the path value will be taken directly to the matrix entries. Otherwise, it will be directly calculated as distance. D of 1 I of I j equal to distance of d I to j. The the final resultant will be having the following entries. A to A is also known as 0, A to B is 2, A to C is 2, then A to D is 3, B to A is 1, B to B is 0, B to C is 3, then B to D is 3, C to A is 2, C to B is 2, then C to C is infinitive, then C to D is 4, D to A is 3, D to B is 3, D to C is 3, and D to D is known as